the worksheet from lecture 7. This is question 3. In these exercises, identify the sample space of the probability experiment and determine the number of outcomes in the sample space. Draw a tree diagram if you feel like it. So, if you were to guess the initial number of a student's middle name, how many possible different outcomes are there? Well, it's literally just the number of letters in the English alphabet. So the sample space will consist of A, B, C, D, etc., all the way up to X, Y, and Z. How many different outcomes are there in the sample space? There are 26 letters in the English alphabet. In number 2, if you were to draw a card from the standard deck of cards, I'm not going to write all of these out, but you can have the ace of hearts, lovely little heart. You can have the 2 of hearts, the 3 of hearts, the 4 of hearts, the 5, all the way up to the jack of hearts, queen of hearts, and the king of hearts. That's 13 different. Let's stick the 10 in there so it's obvious that it goes ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And then we're on to the ace of diamonds, let's say, all the way up to the king of diamonds. We have the ace of clubs, all the way up to the king of clubs. And then we have the ace of spades. Sorry, that's the other way around, isn't it? That's a club. The other one is a spade. Oh dear. 13 of each suit gives us a total of 52 outcomes in this sample space. Part C then is rolling a pair of 6-sided dice. Now, if you roll one dice, you can have a 1, and the second dice can have a 1. There's your outcome. We can have a 1 and a 2, a 1 and a 3, etc. All the possible combinations for when you have one dice being rolled and a second dice being rolled. Now, you can count them. Again, let's just practice our multiplication rule. Something happens on one dice and then something happens on the second dice. Multiply the number of outcomes on each dice and you have 36 possible different outcomes. In this case, what I could do is actually, I'm not drawing this, I am literally just copying and pasting it from somewhere, but we can actually go for a tree diagram just so we can see what one of them looks like. Let's make that slightly larger. There we go. So you can see how these work. You can see that dice roll number 1 followed by a 1, so you get 1, 1, a 1 followed by a 2, a 1 followed by a 3, etc. Or what if you roll 2 on the first dice followed by a 1 on the second, 1 on the third? And from a tree diagram like this you can work out all of the different possible combinations, all of the outcomes in your sample space. But they're kind of tedious to draw.